Hello, good morning everyone. Here I am explaining you 3D printing. Okay, it is too difficult to know about the 3D printing. It is the latest technology. Actually, when you go to the internet, there are lots of stuffs available, but not you are not able to understand it properly. Okay, so here I am explaining 3D printing. There are two ways of manufacturing, that is fabrication, subtractive and additive. Subtractive means most of the ways we are using subtractive manufacturing. In subtractive manufacturing, we are removing the parts day by day, it actually, and each for each time. And in additive, we are adding parts. There are two types of manufacturing: subtractive and additive. In subtractive manufacturing, more loss of material is there, and actually we are eroding that material, so we are minimizing the strengthen capacity of that material. So that is subtractive material. In additive, we are adding the elements and we are strengthening the material. We will able to decide the strength of that material. These are the two ways of manufacturing. Subtractive manufacturing is mostly used for eroding, CNC milling machine, and lathe machine. We are doing subtractive manufacturing. In this, we are directly subtracting the every material, removing the material and creating our product. In additive manufacturing, we are adding the materials and creating the material product. These are the two ways. Okay, next we will go to the next manufacturing: basic principles of rapid prototyping. Actually, rapid prototyping is the past technology for 3D product generation. In this technology, there are different kinds of methods now. After rapid prototyping, there is one more technology is there, that is nothing but additive manufacturing, as we have seen previous slide. In additive manufacturing, we are adding the materials, but in rapid prototyping, we are doing the same thing, but it's a 19th technology. Now 3D printing is there. We will see how this will work. In rapid prototyping, 3D model is generated. It is actually a slice. Each slice is manufactured and layered are fused together. Means each slice is get manufactured line by line, layered by layer. And a voxel is a volume element representing a value of regular grid in three-dimensional space. Means volumetric pixel, or more correctly, volumetric picture element. When you are giving the 3D model to the through the CAD CAM, is representing some value. That value is taken by your rapid prototyping machine, and it is generating that volume by point. When you are providing that image, that image must be in the form of bitmap. Means it is representing a 2D format. Okay, then we will see the methods of rapid prototyping. Actually, there are many methods, 5 to 6 methods are there, but these methods are mostly useful, and they are we are using day to day these methods on basis of application, on basis of cost, on basis of strength. First is stereolithography, second is selective laser sintering, third is fused decomposition modeling, fourth is laminated object modeling, and fifth is a 3D printing, and sixth is, I think, EBM is there. mm, okay, first we will see stereolithography. In the stereolithography, as the image shows, it is a one type of um, poly polypoxide material, as shown in the color. I am representing through the mouse, just see here. This is polypoxide material, and this is one type of filtering material. That filtering material is is assembled in such a manner that when laser light will fall on the polypoxide, it will generate a material, it will make solidify to that resin. So that laser material is used for solidifying the polypoxide material. As it is going to be solidifying, the material will be created, and the what this platform filter material will get down after some time, uh, and then next layer will be created through the laser. We will see it in a video to clear the visualize purpose, for the visualization purpose. It's actually patented in 1986. 3D system is the market leader, highest resolution and smoothness. Because we are using laser technology, it's actually non contacting type of technology. Laser is used to harden the polypoxide material. After that, the material, when the complete material will be created, 3D model will be created, it is kept in a UV rays to strengthen that material. Just we will see in a video. Video will be able to, this is small example of your SLA. In this video, just see, this part is your filtering material. It will goes down, and it is, this box is filled with the polypoxide. When the laser beam is fall on the polypoxide, it makes the hard that resin, and it after some time it will lower down itself. That filtering material will lower down, then the material weight will be its own inertia will be get down. Because of its own inertia, it is the material which is created, it also get down with the help to the filtering element, and next layer will be created. You are able to see it in a video. Okay. Then next is selective laser sintering methodology. It's selective laser sintering can be used here. Thermoplastics were used. Powder is fed into a continuous laser is used to fuse the center of the powder. It is like a printing material. When there is a oval place is there where powder is shrink, or powder is flattered, and on that powder laser material will be hammered, and it get the pattern will be generated. And then next, this powder roller fed will be once again rolled on that powder that pattern, and the this envelope piston, build envelope piston gets lower down, and you are able to generate a pattern. Okay. You are able to generate a cylindrical object, cylindricity. Okay. I know when you see the video you are able to understand it properly. This powder fed into a continuous layer. Laser is used to fuse center powder particle layered by layered. First, when powder is feed with the help of powder feed roller, then laser is bombarded and pattern will be generated, and after that pattern, build envelope piston will get down to some extent, and then once again powder roller field feed to that metal, and once again the pattern will be generated in a such a way that whole 3D model will be generated after some time. This is layered by layer additive 3D printing. Okay, this is the video, you are able to see it. This is generated by Solid Concepts. then it is exposed to UV light, or there is some processing is there. Some processing is there, and then you will able to remove that product out. Okay. Next is FDM. FDM is actually mostly used in everywhere, but it takes requires a huge time for creating a product. High resolution, mm, large footprint is available. With the help of FDM, you are able to create a huge footprint. Low cost is, but problem is time. It consumes a huge time. Here the some small type of representation, diagrammatical representation is available. This is nothing but your extruder head. It consists of two filaments. First is both filaments are for filling up a material. It's additive type of processing, 3D printing. These are the nozzles, and when you provide a type of drawing to that controller, it will generate printing. First, with the help of layered, how you are manufacturing the layered. This is layered by layer processing is there. This is extruder. You will extrude with the on a Cartesian robot. Extruders are thermoplast polymers. These are used means FDM is using thermoplast polymers, so it is as compared with the SLA, SLC. This is very important because thermoplastic polymers, when you expose to the light, it doesn't affected with the help with the light, so its robustness will be much more. Its strength was is also much more. So for that sake, most of the companies are using FDM. mm, Moderately fast and inexpensive. System is starting cost is $14,000. Next is you are able to see the how the pattern of these two pens will be used. Just see here. This is the pen nozzle which you have seen in the image. This is primarily used. After this, next pen roller will be used, so that it will get time to fill these nozzles. And it's layered by layer manufacturing. If I created 5 centimeter cylinder, then I think 10,000 patterns will be there. These are using with the help of thermoplastics, and the strength of that 5 centimeter material is much more than other 3D printing models. This pattern will be generated. The this pattern you will able to use it after some time. Okay. Next is some specifications related to the FDM. Solid filaments, material thermoplastics, ABS is used. uh, Maximum part size is 36 by 24 by 36 inches. Actually it depends on cost, what which type of FDM you have borrowed. Minimum feature size is 0.005. Minimum thickness is of the layer is 0.0050 inches. Accuracy is 0.0050 inches. It's good accuracy. Surface finishing is rough because it's layered by layer manufacturing, and build speed is very slow. So because of only this reason, most of the companies are not using this FDM. Whether why means FDM has good robustness, it provides a good robustness with the help of this advantage, but time is more efficient manner, so most of the companies are not going for FDM. Then third is eliminated object modeling. It's similar like your SLS. There XY optic head is there, and laser beam is inserted with the help of optic rays, and header roller is there. It will roll out like a powder, and you will able to generate a pattern. Object made by the decomposition and cutting of the layers of the tapes. Introduced in 1991, Cube and Helices offers this technology. Slow and sharp edges you are able to create with the help of this technology. And then research on composites, prepregnated modeless manufacturing, inexpensive depending on accuracy, large scale model possible, slow inaccurate, some inaccuracies will be there.